You probably already know how to interpret a standard deviation. Most of us look to Chebyshev's theorem and the empirical rule as a guide for how to interpret it. In this video, I'm going to take a deeper dive into Chebyshev's theorem. Come on.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hi, Mark here from 6 Minute Statistics. Before I begin this topic, let me just say thank you. Thank you for watching my videos. I started teaching statistics over 30 years ago, and I still enjoy helping people understand this topic. Too many times, teachers of statistics make this topic harder than it needs to be. Symbols and formulas are comprehension killers, and statistics is filled with them. I hope you're getting value from my simple and straightforward approach. It brings me joy to think that people are being helped with these videos. All right, enough of that. That's not why you tuned in. You want to learn a little bit more about Chebyshev. So let's start with the basics. Why do we use or even need this information? And the answer is because it works. Always. Not always well, as we're going to find out, but for all types of data. You can never go wrong when working with Chebyshev's theorem. What I mean by that is that Chebyshev's results can be applied to any data set you're working with. The empirical rule, which is the second rule we're going to look at when working with the standard deviation, provides numbers we like better, but it's risky. It only works for mound-shaped symmetric data. If you have that type of data, I recommend checking out my empirical rule video and using that rule. If your data don't have that basic shape, however, Uncle Chebyshev has the rule for you. Here's what he found. At least 1 minus 1 over k squared % of the data in a data set fall within k standard deviations of the mean. That's a mouthful. Let me go through it with you. Typically what we do is we plug in the values of k equal to 1, 2, and 3 and see what we get. For instance, when k is equal to 1, Chebyshev says at least 0%, we plug the value of k equal 1 in the formula, at least 0% of the data fall within 1 standard deviation of the mean. Not very helpful at all. When we plug in the value k equal 2, we find that at least 75% of the data fall within 2 standard deviations of the mean. And finally, for k equals 3, that number jumps to 88.89%, we'll just call it 89%. It's important to note that Chebyshev's percentages are conservative. That is, it says at least. So when it says at least 75%, there's not a data set out there that'll be less than 75%. It's an extremely rare one where you get exactly 75%. So in most cases, you'll have more than 75%, sometimes a lot more. In the standard deviation video, you heard me take this information and make the following standard deviation interpretation. We expect most of our data in the data set to fall within 3 standard deviations of the mean. Been there, done that, you say? I covered all that material in the standard deviation video. I did, so let's go deeper. I'll use an example to explain. A hobby I am passionate about is saltwater reef keeping. In particular, I'm trying to learn how to breed the green mandarin fish. They are such a beautiful fish. But the wild-caught mandarin fish have a terrible survival rate. Those bred in captivity do much better, and it's a project I've been working on. See that little puff of smoke in that video at the end of the video? Those are the incredibly tiny fertilized eggs released by the mandarin. In the wild, they float, and a very small percentage of them ever make it to adult size. My hope is to try to breed green mandarin in a fish room I have at my house. As part of this process, I do some analytics. I'm interested in the number of eggs that are fertilized every time a male and a female mandarin spawn. Let's say that the average number of eggs fertilized is 400, and the standard deviation for the number of eggs fertilized is 100. I want to try to determine what percentage of the spawning events release more than 700 fertilized eggs. Let's begin with the curve of the data. I don't care what you draw here because, as we mentioned, Chebyshev's going to apply to any shape distribution. However, I'm going to encourage you to avoid a mound-shaped curve. That would be better working with the empirical rule, which I'll cover in a future video. Now, draw the mean at the center of the distribution, and then add and subtract 1, 2, and 3 standard deviations away from the center. You end up with a curve with 7 lines. Notice the value of 700 eggs actually ends up being a line that is 3 standard deviations above the mean. Uncle Chebyshev tells us that at least 89% of the data fall within 3 standard deviations of the mean. At least 89% of the egg amounts fall between 100 and 700 eggs in this example. So what does that leave for the percentage that falls above 700? Well, what falls above 700 is going to be the opposite of the at least 89%. So if there's at least 89% in here, there's at most 11% out there. Now I know it's tempting to take the 11% and split it in half and say half fall on one side and half fall on the other, but you can't do it. We don't have a symmetric curve. That's part of the empirical rule conversation I'll have with you later, but when you're working with Chebyshev, our answer is going to be at most 11%. Probably less, and probably a whole lot less. That's the best we can do. How about above 600 or below 200? We're going to do exactly the same thing with Chebyshev, except this time rather than using 3 standard deviations, we're going to use the 2 standard deviation number of at least 75% in there. So we're going to say there's at most 25% above 600. There's also at most 25% above 200. And so Chebyshev can be used to talk about the percentage between k standard deviations or the percentage outside of k standard deviations. Typically we use the values of 1, 2, and 3 for k. However, you could go back to the formula that 1 minus 1 over k squared, and you could use any value of k if you really needed to. All right, so that's my conversation about Chebyshev. What's your next step? Well, watching me do the work should be helpful, but doing it yourself is probably even better. So get to work, practice some Chebyshev problems, and make sure you understand how the 1, 2, 3 standard deviations work and how you can look in between and outside. And then it's on to the empirical rule. Watch my video on the empirical rule to gain more information, and as always, it's time to get to work.